Hello there. Today we are focusing on the addition formulae and double angles. Very quickly. The addition formulae. These are also known as sum and difference identities in trigonometry. The sum identities, the difference identities combined together are called the addition formulae. Okay, so these formulae are essential for simplifying complex trigonometric expressions, proving other trigonometric identities, and calculating the exact values of trigonometric functions for angles that aren't special, like 15 degrees or 75 degrees. These angles are not special angles. 15 degrees is not a special angle. 75 degrees is not a special angle. 105 degrees is not a special angle. 135 degrees is not a special angle. Though they are following the line or the pattern of what special angles. But the very known special angles that we have are the what? 30 degrees, 45 degrees, and what? 60 degrees. Basically. And these are the ones that even your teachers in school, secondary school, and even the lower level, the university, will expect of you to know by heart, commit them to memory. So when they ask you what is sine 30, you should be able to produce it 1 over 2. What is cos 30, root 3 over 2. What is tan 30, 1 over root 3, which is the same thing as root 3 over 3. Okay, so you expected to know those ones by heart. Oh, likewise 45 degrees, likewise 60 degrees. Okay, so one of the very important rather of the addition formulae or the sum and difference identity is that they help us to calculate the exact values of trigonometric functions that aren't special angles. This is not a special angle, not a special angle. And how do we do that? By combining known special angles like 30 degrees, 45 degrees, and 60 degrees. We'll be seeing this later on. But for this video, what we're just going to do is to list the addition formulae. There are about 6 of them. There are about 6 addition formulae. So I'll be listing them for you one after the other. Okay, the very first identity or the very first formulae, addition formulae, is this: sine of angles A plus B. So these are two different angles, A and B. Okay, so this can be angle 30 degrees and this one can be what? 45 degrees. So that's when we are talking about sine of angle 30 plus 45 degrees, which of course is expected to give you what? 75 degrees. And also you can have it to be angle 60 degrees minus 45 degrees, which of course 60 minus 45 is expected to give you what? 15 degrees. So sine A plus B, if you have it after the equal sign, what is it going to be equal to? By the concept of addition formulae, you'll be having sine of angle A first of all, then cos of angle B. Here is plus, here also is going to be plus. Then having it as what? This time around, sine of angle B first of all. Sine of angle B first of all. Then next is going to be what? Cos of angle A. Sine A plus B is sine A cos B plus cos A sine B or sine B cos A. Let me rearrange this so that it will be conventional like the one that you are used to. Okay, so sine A cos B plus cos A sine B. Okay, so that's the first identity. And the second identity is very much like it. So instead of having addition between them, we'll be having subtraction. That's going to be A minus B. And of course, what is that going to be equal to? That's going to be sine A cos B. This is minus, so definitely this is also going to be what? Minus. Then cos A sine B. So that is what we have for the first two identities based on sine. Then the next two will be based on what? Cos. and that's going to be the next identity, cos bracket open A plus B. This time around, you have to be very careful with this. And what is that going to give us after the equal sign? That's going to be cos A cos B. The two cos come first. Now, if this is plus on this side, to the other side of the equal sign is going to be minus. And the minus will now be for sine A sine B. Here it is expected of you to know the concept of pattern recognition. So know the pattern of cos A plus B and know the pattern of sine A plus B. That will go a long way to help you anytime you are working with the addition formulae. Then the next one is going to be cos bracket open A minus B. This time around, what are we going to be having? That's going to be cos A cos B. Still, as this is minus, this will now be now plus sine A sine B. That is what we are having in this case. Okay. Thirdly, we'll be having the tan. Okay. Instead of me just giving you the tan formula directly, I want to do a little switch to that tan formula, so you can see how the one of sine A plus B and cos A plus B can affect that of what? Tan A and tan B. So we are having tan bracket open A plus B, and this is what I'm going to do, because of course we know that tan theta is the same thing as sine theta over cos theta. So this is the same thing as sine A plus B over cos A plus B. See what I'm saying? Sine bracket open A plus B over cos bracket open also A plus B. Of course, so this is a fact. It's also an identity you should take note of, from the fact that tan theta is equal to sin theta over cos theta. Okay, so we'll be working with these now and see how these two identities from this right hand side will produce the one over tan A plus B. So of course, what is the equivalent of sine A plus B? That's going to be sine A cos B, and then plus cos A sine B. So everything over the equivalent of cos A plus B, which of course is going to be cos A cos B. As this is plus, here is going to be what? Minus sine A sine B. But we are not done yet, because this is equals to this, and this actually is equals to this. But this concept of what's it called, addition formulae, was given to us as tan. So we have to find a way of bringing all of this one to become what? Tan also. So they can take the form of the what? The identity that we are starting with. Okay, so how do we bring all of them to become tan? So this is what we are going to have. I'll be working with the numerator, at the center what? The denominator. Now look at my numerator. I'm going to be dividing everything through by cos A cos B. I'll divide everything through by cos A cos B. And in that case, I'll be having sine A cos B, the first part on the numerator, now over cos A cos B. That's the first part. I'll do that to the one on the right hand side of it, plus I'm having cos A sine B. This also will be divided by cos A cos B. Done with the numerator, then I come to the denominator part. Whatever I do to the numerator, I also do to the denominator. So this is going to be cos A cos B, also to be divided by cos A cos B. Then underneath it is minus that I have. And what am I going to be having also? That's going to be what? Sine A sine B over cos A cos B. I remind you my statement again that once you have this, you are supposed to divide everything through by what? Cos A cos B. Let's see if that's what we have done. This is divided by cos A cos B, this side. Then this side is also divided by cos A cos B. Then this side is divided by cos A cos B also. And finally, this side is also divided by cos A cos B. So let's look at those ones that I can cancel out. And then those ones that can give us identities that we are already used to. Okay, so this is sine A cos B, cos A cos B. So this cos B and this cos B, they can take themselves out. Likewise, this cos A and this cos A, they can take themselves out. Coming down, this is cos A cos B. This cos A can take out this cos A, and this cos B also can take out this cos B. In both situations, we are left with what? 1 over 1. Here, is there anything to cancel? Sine A, there is no sine A as the denominator. Sine B, there is no sine B at the denominator. Okay, so what are we going to be having in this situation? Let's see, I'm going to be writing that to this other side. We are left with sine A over cos A because these two have cancelled out. What is sine A over cos A? Of course, that's going to be tan A. Then in between them is the plus sign. This is sine B over cos B. Of course, that's going to be what? Tan B. Then everything over. These two cancel out completely. So we're left with 1 over 1. And what is 1 over 1? That's just going to be what? 1. Then in between is what we have what? What we have is what? Minus. Sine A over cos A will give me tan A. And sine B over cos B will give me tan B. And of course, this is the equivalent identity for tan bracket open A plus B, and that is tan A plus tan B over 1 minus tan A tan B. I hope this is not too rough for you to pick up because everything looks jam-packed because of the space. Don't mind me, I try to make my writing to be so eligible so that we'll not have any issue, and because of that I was using up too much space. But then pick this, tan A equals tan A plus B equals tan A plus tan B over 1 minus tan A tan B. Okay, so the little work I leave to you that you can get out by yourself is for you to find the value of tan bracket open A minus B, just like I found out the one of A minus B for sine, A minus B for cos. So I'm leaving you with this to try on your own, and I can guarantee you'll see that it's actually very interesting. So use this particular concept also, where you are going to have sine A minus B over cos A minus B. Bring out the identities, then do the needful. Okay, so these are what we have. First 5 of the addition formulae. Remember I said to you that there are 6 of them. So I've given you the first 5. I want you to work on the 6th identity by yourself. Thank you. Okay, so by the time I produce the next video, it's basically going to be on the what? The double angles and some other aspects of it, probably the half angles. But let me say, instead of using double angles, okay, double angles, from there we can move on to the multiple angles, and then from there we can have the half angles.